All right. Welcome back to the Ethereum Protocol Fellowship Study Group. This is week 8 on the research track, and we are here with Barnabé Monnot from the Robust Incentives Group, part of the Ethereum Foundation research program. And yeah, he'll be talking today about some MEV and censorship. So I'll pass it off to Mario here, give a little bit more in-depth introduction, and then we'll get started with Barnabé.
Awesome. Thank you so much all for joining our stream today. Thank you so much, Barnabé, for being here especially. And it's an honor to have you here because Barnabé is one of the best experts we can have here to cover this topic. And Barnabé is from the Robust Incentive Group, as Josh said, but he is he's the research scientist, I believe the leader or the leading position of this group, which is doing a lot of interesting research on the game theory of Ethereum or the crypto economics that's happening in staking, but also previously a lot of improvements done on Ethereum has been analyzed by Barnabé and Rick, for example, 1559 models and so on. So Barnabé has a long experience with these topics, and today specifically about MEV and censorship resistance. So we will have a deeper look into some recent economic proposals. Yeah, very excited about it. Many people are excited for today's topic. So thank you so much again for being here, Barnabé. We appreciate you joining us. Yeah, the floor is yours. Well, let's see if we can hear you.
Yeah, thank you for having me. Can you hear me?
Yeah, all good. Go ahead.
Good. All right, perfect. Okay, yeah, I know I was slated to do a talk on MEV and censorship, and I'll definitely talk about that too. But I want to widen the frame a little bit and talk about this kind of conceptual framework that I use to think about the different parts, because there's so much happening in Ethereum all the time. And so this idea of protocol services, I think, is like a good way of trying to map this out for ourselves. So yeah, I'll give like some notes about this, and I'll try to show what might be like a good way to think about it and to organize these protocol services. Very quick intro, though Mario already said quite a lot. I joined the EF in January 2020. I've worked on a couple of exciting proposals since then. Our team, the Robust Incentives Group, now is 7 people, including me. So yeah, we have quite the scope, and we're excited to always dive into the most, I think, tricky questions that Ethereum faces. We have a lot of work that's published. We try to do as much in the open as possible, so do check out our website if you can. And so, yeah, what I want to talk about today is 3 things. So the first thing I'll introduce is very briefly this idea of seeing like a protocol, which is, I would say, my approach to thinking about stuff. So I'll talk a bit about that. And then I want to discuss 2 services that are pretty much like the fundamental services that the protocol is trying to provide, which is first the block production service and then the consensus service. So let me start here. So the idea of seeing like a protocol is you have this abstract object, like the Ethereum protocol, that sort of lives in the sky. That's a network of all these machines. And when you're a protocol designer, like when you're trying to make upgrades to Ethereum, you realize that, okay, there are things that the protocol like sees, that the protocol acknowledges that it can work with, and there are things that it doesn't really see. And it feels like the arc of protocol development is just trying to push the boundary of what the protocol sees and trying to make the protocol like more robust and understand more of what's happening in its environment. So this metaphor of, okay, he can see that and it cannot see that, I'll use that throughout the talk. I wrote a post about this about a year ago, and I was trying to start from the main question of where does this protocol credibility come from? So there's always like calls in the Ethereum community to say, oh, we need to enshrine this, we need to think about that, Ethereum should go in that direction or shouldn't go in that direction as well. There are legitimate reasons to try and scale back also the protocol development, let's say. But to me, the main reason why we want to go in the direction of more updates and more protocol features is because we consider that when something is in protocol, it makes it credible. So suddenly it like gives a superpower to the mechanism that we're trying to enshrine. And so I wanted to question where is this coming from and how far like, should we go with it, or how far should the Ethereum community go with that? And so what should the protocol see? Like how much should we build in terms of features and services? So yeah, I encourage you to check out this post. But a brief TLDR is, for me, how the protocol kind of gets that special power is that it's set up first. So it's not like the primary object. The primary object that sits behind it is this diffuse community of people that I'm a part of and you're also a part of. And this community is trying to set up the protocol so that it achieves goals in a way that's more automated, but in a way that it reduces like the coordination cost. We all agree to participate in the protocol along certain rules that are spelled out in the specification or in the client code that you run. And so that gives the protocol a lot of power, having this community at the back. But the way it sort of goes from being that thing in the sky to an actual thing that runs on your computer is like you have validators and you have full nodes that are supposed to do this work of running the protocol and running these services. And so if the goal of the protocol is this decentralized provision of block space for users to achieve maximal welfare, then you want to question, okay, is that actually what's happening? So when you have validators that are untrusted, that are very decentralized, potentially a large set that you don't know the extent of, do you actually achieve this? Or are there ways for people to deviate and to maybe extract more rent than they should? And so what do these validators do exactly? So I discussed that a bit. The consensus service is the kind of service that is there to give finality to the chain, make sure that we all agree on like the state and the history of Ethereum, on what's happened, like the ledger. And then the block construction service, in a sense, like the liveness service, I think that keeps adding more useful things, more user transactions, more ways for the users to go. And there's a service that's kind of very related to this block construction service, which is the protocol also tries to be neutral in terms of, who can get on chain. And so you have this censorship resistant service that tries to say, you shouldn't be like prevented from going on chain for reasons X, Y, or Z. And so that's also important to have this neutrality. And so the problem now is, you have a protocol with its great aims and grand plans, but you also have the validators who are running it. And so you're constantly trying to figure out like the games that validators are going to play, or that they may deviate from things that the protocol would want them to do. And so the way that we try to control this, or the way that we try to improve the situation is, I think, in two ways. The first is to give more introspection to the protocol, so allow it to see more things that are happening, like what are validators doing, what are users doing, etc. And I'll give specific examples because right now it's a bit abstract. And the second way is, now that you get these signals that are credible, like the protocol knows what's going on, you can act upon these signals. So you give the protocol like ways to act upon this. So you give it agency, and the main ways you do that is with essentially crypto-economic mechanisms of having rewards and penalties and trying to shepherd the behavior of this emergent system in the direction that it likes. Cool. So yeah, I know that the questions are happening in a separate chat room. I'm not monitoring that, but if there's anything, feel free to stop me, Mario or Josh. I'll try to make some pauses as well. Otherwise, no.
Yeah, thank you. No questions so far, but no channel.
Okay, cool. Right. So, that was like the abstract part. Now I'll try to be a bit more concrete and to tell you, what do we mean with like these services? What are people actually doing? What are the validators doing? And so the first one I want to talk about is the block production service. So how do blocks get added on chain and what goes into these blocks essentially. And so one mental model that I'm trying to argue for here is to think of validators as the meeting point between the protocol on one side that regulates the supply of gas. So the protocol says, I'm willing to supply some amount of block space that's consistent with general aims of keeping the nodes light enough for people to run them and for the system to stay decentralized. And on the other side, you have users who have a demand for this block space. So the supply of gas on one side and the demand for gas on the other side. And the demand is represented by transactions. So transactions come in and they're asking for gas. And we're trying to allocate the best use of gas to these transactions. And the validators, they're really like the ones that sit in the middle and that are provided with the responsibility, airdropped the responsibility of making that allocation. And what comes out of this is blocks. So they decide what goes into the blocks and which transactions are being served. So it's not completely unconstrained. Like they don't have. So first there is the gas limit, of course. The protocol doesn't give them infinite amounts of gas that they can just execute for the transactions to consume. But another constraint that's now very important and that went online in August 2021 is EIP 1559. And so this is a fee market mechanism that essentially says the protocol is able to know how much demand there is. So by demand, I mean like how much money people are willing to pay to get on chain. This signal comes to it like credibly. And so it's going to mandate for the users that, okay, you have to pay at least this much to get on chain. So before EIP 1559, there was no such thing. The validator could just include any transaction they want, even a transaction that pays no fee, for instance. But after EIP 1559, you can think of it as almost like an Uber surge pricing type of mechanism. So when the demand is high, suddenly like the protocol jacks up the prices, understands that, okay, there's many people waiting, there's like a lot of demand, people are willing to pay. And so the minimum price that people need to pay to get on chain rises. The way we get this credible signal is essentially by having these double-sized blocks and saying that we want to target a half full block. And so we see if we're above target, it means, okay, too many people want to go on chain. So the price goes up according to the formula here. And if not enough people want to go on chain, maybe because the price is too high, we reduce the price. And over time, on average, we are going to be able to supply the target amount of gas. And so today it's set at 15 million. So that's one constraint that the protocol has imposed. And it's a really clear example of this idea. The protocol gets introspection of how much people are willing to pay for using it, like how much people want to get on chain. And it acts upon it by mandating this minimum payment for the user, which has improved UX and has made the job of wallet, I would say, much easier. And so, we kind of also have this other thrust in Ethereum, or like this other branch of things. We want to scale, right? We want to have more transactions. So EIP 1559 is kind of nice, but it doesn't do anything in terms of allowing more people to go on chain. It just tries to provide good pricing or like objective pricing for them. And so what we really want is then to maximize the capacity of the system. And so the idea of the Ethereum community that was to like go into this rollup centric roadmap, so allow these L2s to become like the way that Ethereum scales. And so what this means is before this EIP 4844 that came online just a month ago, the protocol wasn't really making the distinction between users like you and me who are just going to send transaction to execute some, let's say, swap on Uniswap or something, and rollups who were like publishing all of this data on chain. So the protocol was kind of blind to that thing. And so now with the EIP 4844, what has actually happened is the idea that, okay, we're going to create like a special facility for the rollups, which are almost like power users, to post their data. And the reason why it's a special facility is that the data they post, it doesn't really have the same dynamics as the data that you and I post. So when I send a transaction, I use the call data to call a function that needs to kind of stay in the history. But for the rollups, what they really care about is for the data to be widely available at some point, but you don't really need to store it over time. And so that's what the special facility is doing. And so here again is an example of we are allowing the protocol to have more introspection. Like we say, there's not just like these dumb users or retail users that are using you, but there's also like these rollups which have specific needs in terms of the services they want to use. And so we are going to create a very specific facility for the rollups to do that. And so now again, we have like this new market, and we've kind of increased the ability for the protocol to serve distinct demands. Yeah, so that's exciting. And so moving now to like, let's say the more difficult and esoteric topics of protocol proposer builders version. Yeah, Josh.
Before we move on, got a nice question here from somebody in the Discord, referring to what you said about community setting goals for the protocol. Do you feel that unbundling validator roles into different sub roles like proposer, a tester, delegator, etc., would help the community to better exercise control over validators on the long term, or like ensuring that validators act as the community would want them to? And yeah, would you give your thoughts on that?
Yeah, I can give some thoughts now, and I think over the course of this talk also, I will talk a bit more about unbundling specifically. But in a way, I do think it gives us more control as a community. And the reason is that when you're trying to fit like a very big object into like a very specific door, it's just harder. So the ability to unbundle like these different things does, I think, amplify the control that the community has on the protocols. For instance, if we had said, we want to remain blind to rollups existing on Ethereum, like we're not going to do anything special for them. Yeah, we are not really, like, we're staying at a point in this design space that, in my opinion, is very suboptimal. So by unbundling, like by creating these different gadgets and facilities, I think we do exercise this control and also allow ourselves to decentralize the actors that exist outside of the protocol. But maybe that point will be a bit clearer as I go through the slides.
Cool,
but
thank
yeah,
you.
It's a nice question also to have in mind as we go through all these different roles.
Great. All right. Looking forward to.
Good. Yeah. So yeah, speaking of control, so here I'm picturing what the Ethereum kind of has control over. So it sees what the validators are doing to some extent, like it sees the validators filling the blocks with more gas. It sees the validators doing stuff on the consensus layer that I'll discuss in the next section. It has the ability to give rewards and penalties to these validators. That's kind of how it keeps them in check. But it has also partial control over the way that validators are building the blocks, but not full control. Partial control because of the IP 1559, because of the gas limit, for instance, but it doesn't necessarily see everything that the validators are doing. And in particular, it doesn't see how the validators are sequencing their blocks. So there's no rule in Ethereum in terms of you have to put this transaction first, this transaction second, etc. And that actually turned out to be an extremely valuable power to have for the validators, the power to sequence the block and to even insert their own transactions. And it's something, so this power, or the value of that power, is what people refer to as MEV, so maximal extractable value. And it's really the value that the validator can get from being in control of the way that these blocks are being constructed and the way this control is exerted outside of the purview of the protocol. And so it was not even like the validators, it was the miners first in proof of work. So when the miners figured out that, okay, this thing that I have has value, they soon figured out that, okay, what I could do is I'm going to maybe take part in the construction of my block, but I'm also going to mostly delegate the responsibility of finding out what is this most valuable block to a network of entities that are known as builders, and that will try and entice me to choose the blocks that they're building. So I will say, you know, I'm not, as validator, I'm not very good at making the block, but you guys are the builders. And so try and tell me how much you think you can give me back in terms of value. And so you have this auction happening between the validators and the builders. And the validators are choosing which block to use as a result of this auction. But what's interesting is that all of this is really happening completely outside of the view of the Ethereum protocol. So it really does not know that the validators are delegating this pretty core activity to the builders. And when I say this, I don't mean like all the validators. So with 90% of the blocks today are built from this external network of builders, but there's still 10% that are not. But it's a very significant shift in the, let's say, political economy of who are the parties acting on Ethereum and what are the value flows between them. And so a natural question has been, well, should we move forward the boundary of the protocol? Like, should we try and get a sense of what's happening out there and potentially even like enshrine parts of this delegation so that we resume control of this? And so now I want to show like, these are images from a post that I'm working on, but I've not finished it quite yet. So it's the first time I'm presenting it. But yeah, I'm trying to give here the idea of what exactly is the protocol giving the validators when it's giving it the right to make a block. And so what I'm saying here is the Ethereum protocol originates these rights and gives the validator the right to propose a block that contains consensus data and the execution payload. So the consensus data is all the stuff that attestation, finality, etc. I'll touch upon this later. And the execution payload is really the list of transactions. So that's the thing that the validators today are trying to get built by someone else. And so what we're observing today is MEV boost, so the off-chain network of builders that are, or rather out of protocol network of builders that the validators are engaging to make or to sequence or to build the blocks on their behalf. And so what happens here is the Ethereum protocol gives the validator this proposing right, but the validator creates this new right, which is the right to sequence the block or to build it, and offers that right to the builder. And so says to the builder, you can make the block on my behalf. Like you can tell me what to put in there. The validator will still remain the proposer. So that's the proposer-builder separation. I'm picturing it on the side. Like the validator pretends like the block they made was theirs, but essentially the builder is the one that's building it. And so the first idea to try and enshrine some of these mechanisms in the protocol is ePBS, so enshrine PBS, and more specifically this what I call block auction ePBS. So here the protocol gives to the validator or the beacon proposer the proposing right, and then the validator is going to be able to commit to an execution proposer that is going to reveal the execution payload in a second step. So we are moving from the situation here where everything happens in one step. The validator proposes this big block that contains consensus data and execution payload to a protocol that moves in like two steps. One where the validator reveals this beacon block that contains the consensus data, and that also contains a commitment to someone who will build the block for the execution payload for them. So what we call the execution proposer. And in this block auction ePBS, the commitment is also to the specific contents of the block. So the builders tell the validator, I will build this block for you that has this transaction route. So like a hash of the transaction. So the validator does not know what the block contains. They only know like a hash. They commit to that. And by this commitment, now the protocol will expect in the second step for the execution proposer to reveal the execution payload. And so that's kind of nice because, for instance, if the builder goes offline for any reason, or the execution proposer goes offline for any reason, we can still have the beacon proposer containing the consensus data, which is not the case today. So if there's a failure at any point in that interaction, the whole block is lost. So when we miss a block, we miss both the consensus data and the execution payload. And another thing that's nice is that the commitment that the beacon proposer is making to the execution proposer is kind of guaranteed by the protocol. So if there's a promise of a payment, and if this promise is become canonical, so if the beacon block it goes on chain and is attested to with enough weight, then it's really on the builder's shoulders to propose the block in time. So what I'm noting here as well is that even if we have this enshrined proposer builder separation, it's still possible for the beacon proposer to liaise with the execution proposer using MEV boost. So it's still possible to kind of bypass this whole protocol infrastructure and use MEV boost. So it's not really like EIP 1559 in the sense of, okay, now there's this thing that you have to do, like this price you have to pay, because you kind of are able to bypass it. But it might still be good in terms of providing like a decent trust minimize option for the beacon proposers, so validators, to get into contracts with the execution proposers and the builders. And so I think when people talk about ePBS, they mostly mean this version, but there is a version that's interesting as well, which is slot auction ePBS. And in this version of ePBS, the beacon proposer only commits to who will propose the execution payload. So only commits to the pseudonym or the public key of the execution proposer, but doesn't commit to the contents of the block. And so when the execution proposer kind of wins this ticket to make the execution payload, they might still realize, okay, I could resell the building rights to someone else. And so here, what I'm depicting with the dotted line is that, again, all of these interactions are kind of optional. So the beacon proposer could very well give themselves the execution proposing rights and then listen to offers from a builder. They could also bypass the system and have like a second system to decide who the execution proposer should be. What I'm trying to convey here is that this gives a little more flexibility in terms of you don't have to convince me about what's in your block. Like you don't have to commit to the contents of your block at the time where you're making this bid. You can just buy the right to make the execution payload, and then you may be able to, or you may want to resell the building rights on your side. And the reason I'm talking about this is because this starts to decouple a bit more the beacon proposer with the execution proposer. So the beacon proposer is still responsible for choosing who the execution proposer will be, but it's not the end-all be-all for committing to the block contents. And so just as a quick comparison between the two, in block auction ePBS, the beacon proposer is committing both to who the builder will be and also to the block contents, whereas in the slot auction ePBS, the beacon proposer is only committing to the identity of the execution proposer and not to the block content at this time, and that gives a little bit more flexibility to the execution proposer. Okay, yeah. So these are two proposals for ePBS, let's say two variations of ePBS. But on the same topic of trying to decouple the execution part and the consensus part of the protocol, there's another proposal that I think you've heard about when Mike and Dom came on the call here, which is execution tickets. And now you can think of execution tickets as, okay, validators are no longer choosing who the execution proposer is. The execution proposer is going to be chosen by a market that we call the execution ticket market that is created in protocol and that offers tickets to people who want it. So this market is permissionless. Anybody can come to the market and buy a ticket, and this ticket eventually redeems for them to become an execution proposer. So again, we have the same separation between the proposing right and the building right. So if I own a ticket that gives me eventually the right to propose a block, I am still able to outsource or to resell the building rights that come with that ticket. And that means we might still see stuff like MEV boost and the relay infrastructure in that model. But what's nice and what I depict under the arrow in the bottom here is that because this market is essentially a protocol gadget, we have introspection over okay, who comes to the market and how much they are willing to pay. And that introspection is credible, or at least we can make it credible. And if it's credible, it means we can capture the value that people are paying when they're coming to the market. And here's the distinction between slot auction, EPBS, and execution tickets. We can do this with the ET market because all of this infrastructure is really enshrined in protocol. In the slot auction EPBS, we can't do the burn just like naively. We can't say, oh, whatever amount you're getting here as a beacon proposer, we are going to burn it, because the beacon proposer can totally misrepresent the value of the bid they received for the person to become an execution proposer. And so the ability to say, Ethereum protocol is only going to give you as a validator the beacon proposing right, and the execution proposing rights are going to be given to this protocol structure called the execution ticket market. That allows you to create this burn and this value capture. And this then really also decouples the roles of the validator as someone who's here to provide the consensus data, and the execution proposer as someone who's here to make the blocks and sequence them, etc. Cool. So yeah, I know it's like a lot, and I think spending probably more time on this will be helpful. I'm hoping to publish the post soon enough, but I hope this was at least a nice insight. Okay, so to sum up where we are, we started with this picture of the validators as providing the consensus service and the block construction service, and we ended up at around like this picture where now we have a network of beacon proposers, so the validators in our system who are responsible for this consensus service, and a network of execution proposers who are responsible for this block construction service. The issue now is that, well, we know the builders are typically more centralized. So these execution proposers we should expect them to be centralized and sophisticated entities. And these entities are now responsible in a way for providing the censorship resistance of the chain, which is not necessarily like the best situation. I think we'll be more comfortable if the validators were the ones providing that service. And the reason why is because like we want this decentralization of the operators, because that allows the system as a whole to express a wider set of preferences. So that means when you have like this very decentralized set of validators, and when a block is being made, the validators would include transactions that others, for instance, dislike. If validators are outsourcing the duty of making a block to other people, we're kind of losing the benefit of having a well-decentralized set of operators in the first place, because the people we are outsourcing this duty to, they may not be as decentralized as the validator set. And it's the same thing in consensus. Like we also really care about having a validator set that's decentralized because we want them to be decorrelated, and that creates a lot of resilience in the system. So yeah, allow me to say a little more about this last point. Before that, just checking in if there's any question before I move on.
Yeah, I have a question around the execution tickets and block proposals. So with execution tickets, does that change the frequency a particular validator has to the rights to like propose a block, or what is the mechanism for redeeming an execution ticket?
Yeah, that's a good question, and it's something that's, I would say, is a bit up in the air. Like there is a proposal written by Justin and Mike, which has this idea of, okay, there is this market that exists and you can go to the market and buy the tickets to become an execution proposer. So that means as a validator, if I want to propose a payload, so propose a set of transactions, I have to go myself to the market and buy one of these tickets. So by default, so if I compare with the slot auction EPBS, for instance, in EPBS, by default, the validator is the execution proposer. Like they can give to themselves the right to propose the execution payload. But in execution ticket, it's no longer the case. By default, the validator is only the beacon proposer and not the execution proposer. And when I say, okay, you need to go to market and buy a ticket, this go to market, there's been like some thoughts around this. So in the proposal by Mike and Justin, they imagine a market as almost like an AMM, an automated market maker that just has a supply of tickets and people can just go to the AMM and buy a ticket from it. So like an autonomous structure. But I think there's still a lot of questions on what are the exact mechanics of this and how to operationalize that on chain. So when I want to buy a ticket, do I make a transaction that goes in one of the execution payloads, or is that a transaction that lives in the consensus layer, and who includes that transaction? So all of these, I think, are kind of unsettled questions that we need definitely a lot more thinking on.
Cool. If we want to maybe just pause for one moment, the person who asked that question is typing right now, so maybe they have my follow-up, but give it just a moment. So the follow-up is, so offline validators and double voting would then be slashed retroactively with the execution tickets.
I think you would kind of stay the same. You would look from the validator side, it would look pretty much what they're doing today, except when they make blocks, they wouldn't include the execution payload. That would be somebody else doing that. And so if a validator was, for instance, proposing two beacon blocks at the same height, or if a validator was making conflicting votes that are slashable, they would be slashed according to the same mechanics that take place today. So another validator would include a proof of why validator A needs to be slashed. That proof would be contained in the beacon block. So it really just separates out the what we call the block today that has this beacon part and this execution part in two sub blocks or partial blocks that are delivered in different moments. But from the slashing perspective, it's pretty much the same.
Cool. Thank you.
All right. Good. Yeah, so really what I want to address here is what is the role of validators now, while they've delegated the role of constructing the execution payload to someone else. And if we do move to like this execution ticket world or this validator proposer separation, it's a very big change. So let's look at what else we can think about in terms of unbundling or in terms of understanding like the different roles that the protocol wants to provide. So the consensus service is like very critical. The first, even that you can kind of understand it as different mechanisms that are put together. The first one is LND Ghost. So that's the fork choice rule, but that tells you at any point of time what is the current head of the chain. So you have this chain that is continuously growing. People can add blocks even when you don't have finality. And so you need this fork choice rule to understand, what's the current state of the network and the head of the chain. You have a second service, which is Casper FFG, which finalizes the block. So these mechanisms of 2/3 of validators have to finalize like these epoch boundaries. And then once it's final, yeah, only like a major safety event can happen for the finality to be undone or to be conflicted. And then the third thing is when you take part in this consensus service, you have to keep adding blocks to register new consensus data. So for instance, people casting their finality votes in Casper FFG or giving weights to blocks according to the LMD Ghost fork choice rule. So you have like these three different things that you're kind of taking part of when you are signing up for that service. And so yeah, the world according to the Ethereum protocol, or the world of like validation and people coming in to become validators, is actually pretty small. So the Ethereum protocol understands that people are depositing ETH. So when they do that, when they deposit 32 ETH, they declare, I want to sign up to become a validator. I want to sign up to provide this consensus service. And sometimes people withdraw, so they come out of the thing. And the Ethereum protocol only has this view of, okay, I'm getting like deposits of 32 ETH, and sometimes the deposits are coming out and people are leaving the service. And so why do we actually need people to make these deposits? Why do we need this 32 ETH in the first place? So I'm really going into the, let's say, the rationale of proof of stake. We want people to come and give us this stake because we want to be able, as a protocol or as a community, to say we have a credible commitment to providing good service, to providing good quality of service. And so the protocol can make statements such as if a finality or if a safety fault happens, if finalities happens like in two different places that are conflicted, then I can make the credible commitment that many billions of dollars are going to be lost. And we have this property because we have accountability and we have slashing. So we know that if there is a safety fault of finality, this is a guarantee we can make. And so in a way, the protocol is an actor that demands capital, so that demands people to bring stake to it, so that it can make that commitment. But of course, when people bring capital, there are many incentives for you to try and free your capital. So when you stake, you kind of lock up that money, but capital tends to want to be free. It wants to be reutilized. It wants to be maximized in terms of its efficiency. And so that is why we've seen like the growth of liquid staking protocols that allow you to bring your capital to stake, but also like have a liquid representation of it that allows you to still participate and still have activities with your capital. So make the most out of the stake that you have. And so what's interesting here is that the statement above of if X happens, Y billion of dollars are lost, it doesn't really specify whose dollars. And so when I give my stake to someone who stakes on my behalf, the protocol doesn't really see that, and it doesn't know that, okay, it's not Barnabé's fault that the safety fault has happened. It's Barnabé who delegated to someone who made that fault happens. But this is kind of like not existent. And so the world outside of Ethereum is actually much more complicated than Ethereum thinks it is. You have this long chain of intermediation where if I'm a staker and I want to stake but not directly participate in the validation, I'm going to give my ETH to a deposit contract of a liquid staking protocol, who's going to add that ETH into a pool and then allocate the ETH to node operators who are going to validate on my behalf to the Ethereum protocol. And so all of this infrastructure is really kind of like hidden, doesn't exist in the eyes of the Ethereum protocol. And so really the people or the entities that are kind of treating with or providing the service to the Ethereum protocol are these node operators. And so trying to understand who are these node operators, or who are these protocol service providers, what we see today is really two classes of providers. So there are those that are typically called solo operators. So I would say, or I would define them as people who are a priori untrusted. So we don't know who they are exactly. They don't come with some kind of ex ante reputation that tells me whether they are trustworthy or whether they're malicious or whether they're going to do a good job as operators. So you can think of living room validators, solo stakers who are both running their own operations and using their own capital to stake. And on the other side, you have these professional operators, which are a priori trusted, like you can think of registered companies, big staking providers, like the big names you see. And so when you give your stake to them, you kind of know that, okay, it comes with a trusted reputation. This is like a very black and white kind of distinction, but in truth, it's not that binary. So it's more like you have a credible signal that maybe you learn over time of whether the a priori untrusted operator becomes more trusted. And this valuable signal may be learned by protocols. And so in particular, liquid staking protocols, they may be able to employ like a mixture of both types. So we're seeing, for instance, Lido onboarding some solo operators. We see liquid staking protocols like Rocket Pool, which are mostly composed of solo operators that stake. And so I want to discuss like a little bit some of these constructions now. So looking at the Rocket Pool model, the operator, so the person who's actually performing the service to the protocol, so like the consensus service, can be a solo staker. And to do that, the solo operator only needs to put some ETH as collateral. And then the delegator, so people who want to stake but don't want to perform the service, or who don't want to run a node and become validators themselves, send their stake to this operator and kind of fill the remainder. So I think in Rocket Pool, the operator can pull up 8 ETH, and the delegators can then fill up the rest with 24 ETH. And the operator then stakes both on their own account as well as on the account of the delegators. And so the idea for the operator to put their own money on the line is really to align the incentives and for them to say, okay, you have to do a good job because otherwise your own money will be lost first. So if you get slashed as a Rocket Pool operator, the first money that gets lost is yours, and then the money of the delegators if necessary. So that's a good system. Like, it allows you to onboard untrusted operators into the operations of like liquid staking protocols. But still, it's not the most capital efficient way of going about it. So when you don't have this trust in the operator, you're going to have to require some kind of either collateral or more costly infrastructure to ensure that, okay, they are credible operators. They are not going to rug the delegators. And so the capital efficiency and the cost pressure kind of directives mean that today the liquid staking protocols do rely a lot on professional operators. So when the professional operator comes with like reputation, that's virtual money on the line, but it makes the capital efficiency of the protocol significantly greater. And so there was this idea in the Ethereum community, some researchers have been talking about it, is the idea of, okay, if there is like this problem of trust between operators who may be interested and delegators who are delegating to them, perhaps we can resolve the problem of trust by saying only the operator is flashable. So in Rocket Pool, everybody is flashable. There may be some kind of seniority of slashing, so the operator gets slashed first and then the delegators. But in this model, only the operator can get slashed, and people who delegate to this operator, they can't get slashed. And so now, okay, maybe that's a good model to have as much untrusted operators as possible working on the network. And I think this proposal, in my opinion, kind of comes with like these two premises. So the first one is people want to stake. So I have some ETH, let's say, and I want to do something with it. Like I want to put it somewhere that will give me some kind of return. And so there is this idea of, okay, there's an inevitability that people are trying to maximize and do something productive with their ETH. So they are going to put it into these liquid staking protocols because they don't want to sit on the sidelines. And then the second premise is to say, with this, it's kind of a magic trick. Like suddenly we can make only the people who are actually staking, so the operators, liable. So it's if I get slashed for having delegated to someone who does a bad job, there's no, this doesn't exist anymore. So only the people who have real money on the line are the ones that are slashable. And so that sounds kind of nice, but I think it doesn't necessarily work, or at least I think these premises actually unpack consequences that maybe are different from what they purport. And so the first issue that I see is that people want yield. So when I have ETH and when I'm looking for yield, I'm going to try and find ways to get it. And so if the operator here gets a higher return for putting their money on the line, like they are slashable and the delegators are not, we should expect the money of the operator to kind of earn them a higher return. And so if I'm a staker, but I don't want to perform the operation, I could go to the operator and say, you know, you don't have to put your own money. I can delegate some of my money to you. And so what I think would happen in that scenario is that the operators would end up getting most of their capital at stake from delegators who give them the money. And so we would recreate, in a way, this operator-delegator separation. So even if the protocol was trying to enshrine some kind of operator-delegator separation in that way, the real consequence would be an unbundling, which is at that layer. So the slashable layer would be unbundled between, okay, operators who maybe are putting a bit of money on the line, but most of the stake still coming from people who are chasing yield and willing to be placed under these slashable conditions. You could still have people in the non-slashable tier, so these what I call light delegators that are placing their assets with the heavy operators, even though not slashable. But then the question is, okay, why should they be getting yield, right? So these guys on the left, like the heavy operators and the heavy delegators, they're actually providing economic security to the protocol. Like they're helping the protocol make that claim of, if something bad happens, a lot of people will lose money, including all of these people that are in the heavy stack on the left. So what does it mean for the light delegators to get yield? Like why are we paying them for? Like what is the useful service that they are providing to the protocol? And so this is a post from Vitalik Buterin, protocol and staking pool changes that could improve decentralization and reduce consensus overhead. And in these, he mentioned that, okay, there's a few things that these light delegators that are kind of sitting on the side could be doing. One of them is they could backstop the consensus service that the heavy layer is doing. So the light delegators, they could run their own fork choice and they could kind of check whether the people on the left here are doing a good job with finalizing the chain and making sure that, okay, there's no like foul play on that layer. So they come in as a second layer of defense, almost like full nodes, but in between full nodes and the heavy operators to understand whether, yeah, there is something bad happening on that layer. Another thing they could do in the third bullet point is these people on the right, so the light delegators, once in a while they could come online and create what's called an inclusion list. So an inclusion list is a mechanism to bound the execution proposals in including more transactions. So I'll discuss this a little bit more further. But the idea here is that the light delegators would be responsible for forcing execution proposers to put transactions into their block. And this could be a role that the light delegators are doing here. And so I have this post on ETH Research that I call rainbow staking. And so the idea of how do we organize like all of these different services together? And I think this is a good way to think about it. So on the left, like we have this service of economic security. So the heavy operators that are validating the chain, running this FFG, making these credible commitments of we are not going to do safety faults. And on the right, a stack that is performing these light services, so that come in as backstops or as supplements to the consensus services. And what I think would happen, or what I think should happen, is contrary to this model where the light delegators are kind of choosing heavy operators to do services for them or doing services themselves. I think what we would see is again an unbundling between operators and delegators on the light side. And so the service of sometimes saying, oh, this is what we believe to be the head of the chain according to our light fork choice that we run, or this is the set of transactions that we would really like to see included on chain. I think the light delegators will let some light operators do that. And so by how do we do this? So the light delegators would sort of back the light operators, so give them weight. So say, I believe this light operators is good at providing the service of backstopping the fork choice, or is good at providing this service of making inclusion lists. And so what's kind of nice in this organization is that because this whole light layer stack is not slashable, there's not really like a pressure to rebuild this whole liquid staking protocols with all these trust assumptions and all of this chain of delegations and centralizing forces. And so the light layer, in my opinion, or at least the argument I'm trying to make, should be more friendly to these solo operators that are potentially untrusted. So I might not trust this random person on the internet to give them my money and potentially they can get slashed with it. But if I see them as an active community member on Twitter, doing a good job raising issues on the health of the network, etc., I might say, okay, you know what? I'll back you as a light operator for you to perform that useful service to the protocol. And so this is the picture that we left at earlier, with the problem that the censorship resistant service was kind of pegged to the block construction service, which itself is performed by this not very decentralized network of proposers or builders. But we can redraw that pictures and say, okay, now the heavy layer is going to be responsible for this consensus service that requires this economic security and this credible commitment to good service provision. The censorship resistant service will be done by the light layer, and that will kind of constrain the block construction service. And that seems to me like a more proper economic organization, or a more resilient architecture for the provision of these different services. I have this figure in the post, but I'll just keep that. So just one last thing before I finish. I mentioned like this idea of inclusion lists, so a way for people who are not directly involved with the block production to force the inclusion of certain transactions. I think to me, like the real definition of this mechanism is, yeah, a way to make the most out of the decentralization of Ethereum. So we have all of these different stakeholders that are in different places around the world with different preferences, and having this decentralization force kind of the block production layer to not play games, to not extract rents with the inclusion or not of the user, I think is very powerful. And so you have this EIP 7547 on inclusion list. Our team has also opened like this open problem looking into different gadgets, so committee-based inclusion lists that increase even more the pressure to to include transaction. And I think the key goal here is this idea of block co-creation. So you maybe have like a very centralized layer making the blocks, but you're trying to bring back the force and the pressure of decentralization on the makeup of that block. And so you're really trying to get that transaction input on chain and get the users on chain without games being played. All right, yeah, that was a bit of a rough end, but I hope you enjoyed the presentation and do check out our work at the website.
Awesome. Thank you so much, Barnabé. Yeah, that was great. It's a lot to digest with the inclusion rainbow staking. Let's go all the way back to the EPBS because we have some questions on that. And that is whether there are any existing mechanisms, any ideas for addressing the bypassability in EPBS so that validators can still go with some external tooling. Yeah.
Right. So there was a mechanism, I mean, there still is, I would say, a proposal, MEV burn. So the idea here was trying to constrain the beacon proposer to, they can't pick whatever builder they want or whatever execution proposer they want. So the MEV burn mechanism was using the power of the attesters, who are the other parties involved in the consensus service, to kind of observe the bids that are flying on some gossip channel and force the beacon proposer to choose a bid that maximizes the value. And so that's one way to resolve the credibility problem where the proposer is in control of choosing who the builder is. I think, yeah, it's a difficult mechanism, and there's been a lot written about it. One of the difficulties is the auction for the bidding rights. It's kind of happening at the same time as the block value is increasing. So the auction happens, and while the auction happens, you see more and more transactions trickling into the mempool, and so you're kind of trying to bid on the value of like a value that just changes while the auction is happening. And this sort of circularity, in my opinion, makes the mechanism pretty tricky to operationalize in practice. So I don't actually think the bypassability will be fully resolved. Like even if we look at execution ticket, yeah, we have this credible bid in a sense, like we have people coming to market and telling whether they want to buy the ticket or not. But once they have a ticket and once they become the proposer, they might still want to outsource the building to someone else. And so, yeah, I think in many different places, like we don't really see the kind of trusted stack of MEV Boost disappearing, or at least it's very difficult to do so.
Interesting. Thank you so much. That's really great. The next question was to elaborate on the MEV burn, which you already kind of did. So yeah, thank you so much for covering that.
Okay.
Yeah. But then more about the rainbow staking, where it's so interesting to be able to have like sort of trustless rocket pool kind of staking pool. But what are the other implications, like for example on restaking? Because people here compare it to, like, it sounds like enshrining restaking. I'm not sure about that, but yeah.
Yeah, I think there's very interesting parallels, and definitely I think a lot of these ideas are coming from also observing how restaking has developed on Ethereum and sort of like the ideas of people around this. So just like briefly, the aspect, restaking is like very deep and there's many ways to think about it. But the aspect that I think is relevant here is the idea of adding more protocol services in this permissionless way. So restaking is almost like you're adding services to what the validators are doing, but in a way that the Ethereum protocol like doesn't really see it. So I don't know as a protocol that you've restaked to promise that you would provision some EigenDA bandwidth for data availability service. That this is not something that the protocol is aware of. What I'm describing here in a way is the ability to have this interface of, okay, you have different services that we could decide to plug in the future. For instance, we might think, okay, inclusion list is a good idea to have as a in-protocol service, and that goes into the light stack. Maybe there are services in the heavy stack that make sense. So economic security is mostly useful, in my opinion, for yeah, things like safety faults, so FFG. But there's been a lot of discussions around pre-confirmation. So these need economic security because you're trying to make this credible commitment of, okay, it's a promise that has value that I make. I pre-confirm your transaction and I promise you that it will be included in this block or in that rollup. So there are like different things that require economic security. There are different things that require more a widely decentralized set of operators that don't necessarily need to be slashable. So yeah, I think what I'm describing here is a nice interface for plugging in these new services to the protocol in a way that mirrors the restaking services which are out of protocol. I'm still trying to think through like the links between the two. I think it goes probably a bit deeper than this, but there's definitely something there in terms of thinking of a protocol as trying to provide all of these services in a way.
Thank you. The follow-up on this is whether you could expand a bit more on the heavy services, how to think about them, but also whether pre-confirmations would fall in these heavy stack.
Yeah. So I think the best way to think of a heavy service is to just observe what's currently on chain today. It's really just people doing the work of signing these votes, attestations, and yeah, getting the network to come to finality. What I'm saying in the post, or what I'm maybe advocating for, is we can add like these new gadgets to Ethereum. So there are many proof of stake protocols out there in Cosmos, in Tezos, Cardano, that have different ways of doing things, and some of them have much less, let's say, bare bones approach to staking. So one thing that was, or that is often reproached to Ethereum is you don't have like in protocol delegation, and so that means this is why you have Lido, this is why you have all of these big pools living on top. Yeah, there's many like historical reasons. I think it was a semi-conscious choice to go in that direction, but that doesn't mean we have to stick to it. So there is this impetus of, okay, maybe we need the protocol to like do more about this. We need to enshrine more things. So again, with like that same drive to, if we don't see it, we can't control it, and so let's try to enshrine. And so what I'm describing here is not what I would call enshrine liquid staking, because that, in my opinion, is not possible. Like you have to, if to enshrine liquid staking or to enshrine something, like I'll take Lido as an example, but it's true for all of them. Like you would have to enshrine the ability for the protocol to curate this set of node operators, and that introduces, in my opinion, things that may be going too far. But you could still enshrine like gadgets that try to lower the barriers to entry for the market of liquid staking protocols, so that make it more competitive, so that you try to prevent dominance of one single protocol that maybe has captured some edge. So leveling the playing field, adding all of these gadgets of, okay, you can have native delegation that can be made fungible into a basket of shares. I'm thinking of a liquid staking module which exists in Cosmos here, and that I also mentioned in the post. So there are many ideas I think that we could borrow from other protocols. Which ones are kind of the ones we should settle on, I don't really know. I also need to do more research myself into this, but I'm just kind of excited to opening it up, and it's something that's been discussed quite a bit, both on Twitter and via this post by Vitalik, Mike, Donkrad, Erickson. So it does feel like there is some kind of rethinking of, okay, we should be doing something about it. And what I'm trying to say here is this is how we should be thinking about it when we are trying to do something about it.
Thanks so much. This is a very interesting topic. There is another question on the differentiating the heavy and light. Like from what you're saying, I imagine that the heavy services would be kind of similar to what the seekers are doing today, just like running the full stack basically with all the responsibilities. And this would be the higher yield. So the question is like, what is actually the motivation to run it as the light? To quote the question, why wouldn't the heavy operator continue taking the capital and run it all as heavy sloshable capital if it's higher yield? What is the incentive to run this light, since we know that disinterested delegators often don't pay heed to small differences in the risk factors. And we know that sloshing events rarely affect delegators since protocols often cover those events.
Right. Yeah. There's many layers to these questions. Maybe I'll go like in the reverse direction. So if there is some kind of insurance on the risk that you're taking, like if you're staking with someone and that person says, even if I get slashed, like nothing bad will happen to you. Yeah, that creates moral hazard, which is like this idea of, okay, if I have insurance, I'm going to be more prone to maybe having accidents or stuff like this. So I'm going to be, it will definitely like lower my my perception of the risk I'm taking. This is not really something I think that the protocol can really address fundamentally. We're not going to, let people report to the protocol, oh, this delegator or this operator is offering insurance, etc. Like it wouldn't be credible, so it would be very difficult to control. But I do think, when in terms of a distinction between heavy operators and light operators, this is also again like something that I posted pretty recently. There's a lot of unknown unknowns and questions that I'm not like even myself fully clear on. But I think what could happen is very much people who are heavy delegating, like they wouldn't have to choose between heavy delegating and light delegating. Like they could do both in the sense that they could restake their heavy delegation into the light services. So they could still kind of provide this useful service of surfacing who are the light operators that are doing a good job at censorship resistance or at backstopping the heavy operators. So from the heavy delegator perspective, they wouldn't have to really choose. Then I'm not sure if I understood, but I think one part of the question was, why wouldn't the heavy operators just become light operators themselves and crowd out these solo stakers that we would want on the light operator stage? This is again very speculative and something I'm trying to think through. But the idea here would be, I might trust Lido or Coinbase with my assets when it comes to the heavy delegation, because okay, they run their operations well, it's kind of like money on the line, etc. But when it comes to choosing a light operator, choosing like who I back as the provider for light services, I might use different signals. Like I might say, again, there's this guy on Twitter that always has good takes on how the network is doing, so I'm going to back them with my stake. It's almost like not staking in that regard. It really looks like token curated membership in a way. Like I'm just trying to say this light operator is doing a good job. So we can't have everyone on the network trying to make an inclusion list. Like that would be impossible to process. So we have still this leader selection problem of figuring out who are the people who should be making the list, or who should be like making messages for the protocol to read and to execute on. So how do we select these leaders when it comes to the heavy operations? As a staker with money on the line, I might select like conservatively. I might say I really require like credibility, which means I want to go to like liquid staking protocols that are credible. So Lido, for instance, is kind of nice. It has both professional operators, in the future also solo operators. That to me is pretty, it shows resilience, so I'm willing to put my money to them. But then when it comes to the light operators, maybe I have a very different preference function based on the fact that, yeah, I'm looking for different things now that it's not just a money problem, let's say. Yeah, I'm not sure. There was like many points in that question. I hope I answered them.
Nick, let us know if we didn't answer all of the questions, but I'm sure you also have a chance to chat with Barnabé elsewhere. But yeah, this is yeah, all answered. Thank you, Barnabé.
Okay,
yeah,
cool.
this is all very fascinating. Yeah, with the delegation and like voting, as you said, or like it reminds me, I'm having flashbacks. Like many years ago, there was a big thing, delegate proof of stake, which some chains were implementing, like 2017 or something like that. So, what is the maybe difference between like those like DPoS designs and what would become from the proof of stake here? Yeah.
Right. I mean, it's hard to say because again, I'm not like claiming a specific design is better than others. I do think we want to, or like, yeah, there's a strong will to keep this idea of it's as permissionless as possible to become a validator. So today it is permissionless. Like anybody who has 32 ETH can just come in and stake it and be activated as a validator. At the time of, I think when proof of stake was starting, I was just joining VEF actually, and there were discussions of, okay, early delegated proof of stake networks, they exhibit very strong power laws. You have most of the stake concentrating to like a few big trusted providers. Obviously, it was very early anyways in proof of stake, and many things have changed since then. So yeah, I feel like there's just like designs that they still look like delegated proof of stake in the sense of the protocol has some native representation of there are people who are operators and there are people who are delegators, but it can be more subtle and more nuanced about the shape of these agreements. So it can say, and that's one thing that the liquid staking module does is when I delegate my stake to someone, I can mint that act of delegation as a share, and I can then provide that share to a liquid staking protocol who's going to aggregate all of these shares and kind of curate a basket of shares. So based on its own, let's say, internal business logic of saying, oh, I'm getting too many shares of like that single operator, so I don't want more because then I rely too much on them. Yeah, so there's like a lot of heterogeneity in even what people call the delegated proof of stake. There's protocols also who have stuff that's called liquid staking that I don't think is exactly like liquid staking protocols as we understand them in Ethereum. So yeah, I feel like a lot of the effort will be to translate some of these ideas into proposals that actually make sense in the Ethereum context. And there's been definitely like work on this. So Ericsson has a really nice post on that. Yeah, it's something I'm just pretty interested in. I would call that the staking user experience almost, like how do I as a staker interact with the protocol mechanisms, and how should these protocol mechanisms be thought about in ways that preserve the values that the Ethereum community kind of looks for in its protocol, which is, yeah, as permissionless as possible, but also useful.
Amazing. Thank you, Barnabé. Yeah, it's like I understand it's more vague definition there of like the depots or stuff like that. So yeah, thank you so much for answering that.
Sure.
We have a comment and question from Nagu, who, by the way, wrote on our protocol studies wiki whole page about EPBS, and he wants to thank you for the article on PBS where you said PBS is design philosophy, that it's a beautiful piece of work. So he asked how long did it take you to write it? And a follow-up question is whether you have any advice on how to think about these open problems, how to analyze them, where to study more, what to study. These are very fascinating problems.
Yeah. So yeah, I guess the first question was how long did it take me to write it? Yeah, if I remember, not that long actually. So, and this is probably pretty specific to me, and I know that many people work differently. I tend to be very quiet for a while, just accumulate input for a long time, and then like the dam bursts, and suddenly like I can just write the whole thing. And I think this piece I wrote the bulk of it on like a Sunday afternoon when things kind of just clicked like the different ways. Then of course it took me more time to polish it. What's really nice with this community is the wide network of collaborators and people being really available. So I think I sent it to people in my team, people outside of my team to kind of give comments. So that cycle also takes a bit of time. But yeah, I feel like when I started being able to articulate the way these different proposals kind of click together, then it was not very long to write it. And kind of same for the Pepsi post, kind of same for the rainbow staking. Just at some point it just comes in and then it will take me a day to just put the whole thing on paper and then more time to review and really polish it. So yeah, one so how do you get to that or how do you like get more? Um, I think the best way is to read as much as possible, like just any paper that has been written or post or blog post or talks. There's so many talks that are available. What's really nice is like nice and also sometimes terrifying is the wealth of information on all of these things. Like it doesn't make sense. And one advice I often give is to make your own way through it. Like don't be afraid to repeat arguments that people have made, like even write them for yourself, but always try to like put your own spin on it. So when I was doing EIP 1559, I was simulating things. So I'm not like a great programmer, but I can do basic stuff. And so my way of understanding EIP 1559 was, oh, let me code like little toy examples and progressively make them richer and richer. If you're more like a abstract person, just try to draw things. I'm also very visual, so I like to put all these boxes and stuff. If you're more into data, find a data set that's relevant to it and maybe just explore it, like try to find, can you prove empirically stuff that people are only talking about kind of theoretically. So yeah, the best way to go about it is just narrow your focus to like a specific thing that you think is kind of like curious or you're like, I don't think people have understood it quite well enough and I need to like bring more of that understanding and then just decide on what's the best angle of attack. And that's really personal in terms of what suits you best. And yeah, last thing is don't hesitate to reach out, like both myself and anybody I work with. I know we obviously have limited bandwidth, and sometimes my Telegram also is exploding. But generally, I'm always happy to help in as much capacity as I can to review or to even just like get on a call and shoot through ideas.
Amazing. Yeah, thank you so much for that, Barnabé. And also, you are in our Discord server there, so I believe people might ping you there. Thank you. If they have any questions, I think this is a great point to wrap up. We have maybe a few more minutes, but I think we can finish it here because we have no more questions, and I think we should open another kind of war so we can do it in Discord. Yeah. Awesome. Yeah, thank you so much, Barnaby. Again, I really appreciate your time. I really appreciate you guiding us through all of this because it's all very new. It's all quite complex and hard to grasp. So yeah, thank you so much. I really appreciate it. And yeah, we'll see you around the Discord and the protocol.
Yeah, sounds good. Thank you both, and thank you to the people who attended.
Thanks so much, Barnabé. Always fascinating to hear you speak.
Cool. Bye bye.
Cheers.
So bye bye. We'll see you next week.